I'll put my email address on here as well.
Okay, so let's start, and I just click on the record. So we'll record it, and those who couldn't see it, they can, they can check the
Yeah,
check the recording. Okay.
Okay.
So go ahead, Mark.
Yeah, super. Thank you very much, everybody, and nice to be with you. My name is Mark Lucas. I head up the EMEA pre-sales systems engineering team. One of my colleagues who will be joining this call a bit later on, David Ranson, he is actually on another call, but will join as soon as he can. Any questions after this session, obviously, you can email us, mark@weka.io, and that's david.ranson@weka.io. So what I wanted to do today as part of the first session, we're going to be running 2 sessions, this one and another one that follows soon, which is an hour, is to just go through why people deploy Weka very, very quickly, no sales, and then literally just around how you would consume and use Weka in the lab. And then what we're going to try and do at the very end is just get onto a system, start to show you around, give you some areas to go and look at and do some reading and find out more about Weka and how you deploy it. And again, what we will also do is probably open up a Slack channel for anybody in the teams that want to reach out and ask questions. And what we can also do is, or a Microsoft Teams channel, we can also do that as well. And obviously give you license keys and any of the software links to download Weka to use it. So one of the key things that we talk about here with Weka, why is it important for AI workloads? And I'm currently at the HPC AI show here in Lugano in Switzerland, and it's around flexibility, better performance, client quality of service. But what Weka actually is a piece of software. It's a parallel file system that has been designed from the ground up to support AI workloads, and you'll see more around that. The key value proposition about Weka is its scalability and speed, and also how we do things like data protection. So let me just drive you a bit about history, what we see in the field, and hopefully as students you see this as well, is historically for AI workloads, people would have this type of environment, and they would use a HPC type of environment to do their AI workloads. So they would typically on the left-hand side have a GPU cluster. This could be a DGX A100 or another type of AI cluster here running. And what they would actually do is ingest data from the field into a typical NAS deployment, something like an Isilon. They would then copy the data to some sort of parallel file system like GPFS or Spectrum Scale or BGFS or Lustre. They would then use this as a scratch trace, do their workloads, do their train, transform, validate models, copy the data back. They would also copy the data over to another system. And at the same time, they would also deploy that data through a data mover into a lake for things like Hadoop and Spark, and then send that also out to tape. So what we do at Weka is we are a software-only solution. We run on generic x86 hardware. And what we're going to do and show you later on is you can download Weka, this software. And the whole reason people use Weka is they want to get really, really fast outcomes of their API and GPU workloads. So one of the key things is predictability. So you'll hear a bit more about that as well. And then as they add more and more jobs into their AI pipeline, what they need is extensive scalability and a repeatable measurement. You'll see this as well. So faster outcomes, they need to get the result from that GPU workload to a point where they can use the results, and that gives them a competitive advantage. So let's just talk about very, very quickly an AI pipeline. And this is what we come across every day. So as I said before, we're having people that will ingest data into their pipeline, and that can come from many different resources. That can be from machine generated data, that can be manual edited data, that can be from the World Wide Web, clear text parsing data. They will then put this into a ETL model, which obviously needs indexing, searching. They will use the cloud to do this as well. They then start to run their training models on that, and their validation models and their inference models. And then once they get the result out of that pipeline, they will create an archive. All of these steps, Weka can speed up. So if you're thinking about Weka for this lab result, this lab thing, these are the types of models when you go outside and you leave education that people will be using AI for. So lots of these things, we have a lot of white papers on our website discussing that. So we speed up this data pipeline. So the key takeaways are we're very energy efficient. Doesn't really matter for the lab experiments we're going to be doing with you guys. We've got exceptionally good performance at scale. And I think we will have challenges just running Weka on a single server showing really good performance. But certainly we can demonstrate some numbers to you and with you so you can build that yourselves. And then we have intelligence about where we put the metadata and how we stripe that metadata into the cluster. So that's great, Mark, lots of marketing terms there. But what actually is Weka? So here I have some Linux machines. These will be on-premise or in the cloud. And these are physical x86 servers running Linux, Red Hat, Ubuntu, CentOS, Rocky. We have a list of supported OSs. Inside this Linux server, we have NVMe, non-volatile memory express. And what we're actually doing is inside this physical server, you have a CPU, you have DRAM, you have memory. And what we will also do is place in a network card or multiple network cards. This can be a InfiniBand card, it can be an Ethernet card, CX5, CX6, CX7. And what we actually do is we download the Weka software onto each of these Linux servers, and we glue them together to produce a unified POSIX namespace that a GPU client, and this is your A100 or your DGX box, can connect to. And the reason Weka is used here for this type of model is historically, and I was discussing this today with a few people, is people have gone out and they've bought a single DGX box or they've bought two DGX boxes. And what they need to do is they need them to run quicker. They need to get the simulations through. They need to do their AI workloads. They're running multiple inference across their data pipelines. And then what happens is the CPU, the GPU is running at 100%. Their PCIe bus is completely full. And what they end up doing is buying a second server, a third server, and you end up with islands of data. So what is better, and the better way to do this, and this is how Weka addresses this, and you'll see this with the labs, is we have a single server, and we say, don't put NVMe inside this GPU box. It's too slow. Don't use RAID. Don't use any type of striping for disks. It's all too slow. Connect this box via a high performance InfiniBand and Ethernet network, 100 gig, 200 gig. And basically what we do is we take that file from the GPU directly through the network. We bypass the kernel and we stripe the data. And this is really important across the nodes, the back-end Weka nodes. So we're writing data in stripes and in what they call an erasure-coded stripe across the NVMe. And what that is doing, it's allowing our GPU box to get huge scalability. So the I/O and all of the wait times and the kernel times and the GPUs that are waiting on that internal storage are now released to do what they're designed to do. And then basically what's happening is the data is being read across this cluster. So obviously for our lab, we don't have the ability to have multiple clusters here. So what we're going to try and do is have a single machine. And then what we're going to actually do is, rather than having separate Weka instances on separate servers, we'd probably connect it to a network, and we will actually virtualize this inside a single machine for the lab. So you have Weka running on this single machine. So the idea behind this is to stripe the data, expand the data, grow the data, but the most important thing is to introduce predictability and performance into your GPU workloads. So historically, what's happened, if you look at this, is people have started a job or a GPU process, the storage goes up on the local node, and then what happens is as it starts to reach a maximum, the storage plateaus out and it actually starts to go down like this. If there's a failure inside one of the storage elements and a part of NVMe goes down or a disk goes down, what actually happens is the performance starts to go down as it's dealing with that failure. What Weka allows you to do, based on sizing this, is to stripe the data, as I said before. But what we do is we introduce, and this is a great thing to think about for the labs, the ability to have a server. It starts running Weka, it grows up, and it will reach a threshold on the back end here on this single server where you will get predictable performance from that single server. So this is what we're thinking about doing. Obviously, we don't have the luxury in the lab. We don't have the luxury at ISC to have multiple servers glued together. But what we're thinking about doing is running a multiple instance of Weka, these separate nodes glued together in a single server that's basically doing this type of role. And we call this multi-container backend on a single server. What it also allows you to do is have the GPU connect, and we won't be able to run this, it's a shame, but we can connect this server to the Weka cluster running GPU Direct. GPU Direct is some software that's available from NVIDIA. It's a set of libraries that allow you to optimize your AI workloads and GPU calls. And what it allows you to do is write via RDMA directly from the memory bus on the GPU host to the Weka cluster. So very, very clever technology. I think really for the labs, and also please jump in if there's anything around that you want to add, I think that will be a bridge too far. There's no benefit at all running that on that single host. Any questions on that at this stage? No questions? Okay, so that's what Weka actually is. Hopefully you can still see my screen. And then literally what we're also going to do is discuss what's going on under the hood, what's actually happening with Weka. So here is my Weka server running, and you can see it's a Weka POSIX client. And what we're actually doing is, this is your DGX box running. We have a DPDK card, and this is an NVIDIA card, or it used to be a Mellanox card, 6665. And what we're actually doing is we are running in our own memory space. We are leveraging a technology called DPDK. And this is an open standard, it's an Intel library. And what this is actually doing is we are bypassing the kernel on your DGX box, because the kernel is interrupt driven, as you're probably aware. What we're using is this toolkit called DPDK to bypass the kernel. And so basically the application is writing not through the kernel, but through the Weka POSIX driver directly onto the network, which is then served up by the backend clients, which then writes it down to a multiple SSDs at the back end. And this is what drives, this is the glue that allow Weka to run this in a polling mode. Any questions on what's going on under the hood? No? Okay, so let's actually get on. I'm just looking at the time of what we've got, how far we were going at this stage. So one of the key things we need to think about for the labs is how are we going to set this thing up? How are we going to run it? And what advantages does it bring? And so using this single server, and I said David Ranson, who's, I don't know if joined the call yet, but we can hopefully check in with him as well, is we're going to help you go through this in the second session. We're going to show you the building of the Weka cluster. We're going to give you scripts that you can set this up. We're going to show you where to download the software from, so you can actually have a look at this. And we're also going to go through and explain to you some of the other options that you have and can learn and play with Weka ahead of the lab. So what we normally do is, to get Weka up and running, we run a technology or a script, a Python script called Weka checker. And what this actually checks is, it's a Python script, and it goes off and it checks all of the things we would expect to see on a Weka cluster. So what it firstly does, it checks to see if there's any jumbo frames, and we support jumbo frames and would enable jumbo frames. Because you've only got a single server, obviously there's no value to enable jumbo frames on this one. We will also look at the data plane that connects the Weka servers together. We will check, obviously, that we have SSH to all hosts. Well, we don't need to check that on a single host because it's obviously there. Time is very, very important. NTP for time needs to be enabled on the cluster. And then there's a series of different checks. One of the most important ones is to have space. There's a mount point called opt Weka to make sure there's sufficient capacity. Available DRAM, the minimum we're going to need is 128 gigs of DRAM, more if available. Internet connection's not strictly true. We can download the software, but it'd be good to have that if you're using a cloud type service. We don't need that. DNS, again, we're not going to need that as part of the labs. We check also that the client running the storage element has it got some sort of firewall enabled on it? Are there any ports being blocked? And also we check the packages. There's some packages like XFS progs that Weka needs on that server. And then we also check that if you're running InfiniBand, that there is a recommended offed driver that we also do. The other thing we also recommend and check is things like, is the kernel supported? You're not running a really old, out-of-date kernel. So we have some lists of approved kernels on the website. We also check the old school things, is Network Manager running? Because obviously we're running over the network. We also check to make sure that NUMA balancing is there. So Weka's really, really good at performance. And what we've noticed on back-end servers, particularly with maybe AMD processors, that we used to have multiple sockets with multiple NUMA regions. What Weka does is you can pin CPU cores, you can pin the network card close to the region that needs it and the CPU that needs it. Again, we won't need to do this as part of the lab experiment, but in the future, as you scale out Weka, you can do this. And then we check for all the things like IOMMU. We check to see if RPC bind's enabled and a couple of things around that. So Weka Checker is a tool that you'll get to run. You'll run it on that local host. We will show you that on the next session. This tool can be downloaded from Git. I'm going to cover that in a minute. A lot to take in. So what are we talking about when we talk about Weka for multi-container backends? What does that really mean? So this tool here is a script that we allow you to run, and it will ask you, and it says, how many CPU cores do you have on your backend storage node? I have 24 cores. And what I'm going to do is nominate so many CPU cores to do the storage in the drives. I'm going to nominate the number of hosts. Well, in this case, it's 1. And then what I'm also going to do is look at the front end cores. What are we doing in terms of the protocol? Well, we've been using our own POSIX client, so we only need really 1 front end core. We're going to look at the number of drives. Again, we only have 1 or 2 drives, so that will be 1 or 2. And then we will look at the compute cores, and this does all the historical erasure encoding and that striping of the data. All of that is hit through the compute cores. And then we give it a cluster name. And then because we're not using RAID, and it's really important, RAID is, it's designed for disks. Weka has been built from the ground up. It's actually for NVMe technology. So even an SSD that doesn't have NVMe, we can't really leverage the performance. What we expect is to see inside the server at least 1 or 2 NVMe devices that we can run. And we have a thing called a virtual hot spare as well. So single container backends, and again, I'm not going to go through this at the moment. This will be shown in the next session, but you'll see outputs where we've actually listed the Weka servers, and it will be showing you which compute resources, which drives, and have been associated to a CPU core. So let's move swiftly on. So NUMA regions, again, that's normally something that we need to talk about. We're not having to do this today with the lab test that we'll be running with you guys to build. So but just be aware it's there, it's in the documents. If people ask you about it and you're thinking about NUMA regions with Weka, how does it work? We can pin cores, as I mentioned before. And then what we're also going to do is we'll cover off some of the commands like Weka local resources that you can list out what's going on each of the Weka nodes. So let me just go back. I just want to go back to our original diagram. So what do I need to get Weka up and running? Well, I need at least a single box, normally 6 servers or 4 servers, but we would typically have 8 in an environment. For the lab, we will actually just grab 1 physical server. And then what we will do is run multiple Weka containers on that server here. What we're also going to do is we're going to connect or allow you to, try again, erase all the ink. We're going to allow you to connect a single server, a GPU server up here, or multiple servers if you've got it, to that Weka cluster, and hopefully get some benefit in seeing the performance being offloaded, offloaded by the GPU server itself. And again, we are going to look at looking to see if we can add more machines into this environment to give you even better scalability. So a lot to take in at this stage. Is there any questions so far about what Weka is and how it's presented? No questions? Fantastic. Okay, so what I'm going to do now is literally just take you to the places that you're going to need to learn and go and have a read around. So I've been talking for 25 minutes so far. What we're going to do at this stage is actually show you a Weka cluster live, just walk you through some of the basics about how you look at the commands and where you go. But the most important area is to have a docs.weka.io. So please, everybody that's looking at this, just going to quickly put this in the chat so we can actually see this as well. And I will send out a link to everybody. This is a really, really good place to start to learn about what Weka is and what I've been talking about today. It has a lot of pages around where you download the software, how you install it. You can even run Weka in the cloud, but that's obviously out of scope for this project. The key thing about it, I'm just going to quickly paste this in now. Let me just put this in the pasted chat. I'll quickly paste this in a second, actually. Stop presenting, stop sharing. I'll just quickly paste that in. Oh, Dave, you're there. Good stuff. Thank you. Do you want to introduce yourself quickly while I'm just pasting that in?
Yep. Hi, I'm sorry for being a bit late joining us on another call. I'm Dave Ranson. I'm one of the pre-sales engineers. I work for Mark in Europe, and I'm going to be here assisting Mark and helping you, anyone who needs any assistance from getting Weka running.
Fantastic. Thanks, Dave. So, right, so back to sharing my screen. Hopefully you can see that. I'm just going to quickly go back to sharing now. Not now. Screen. So this is docs.weka.io. It is the holy grail. Everybody goes here for questions, and it's broken into multiple different sections. What I would do is I would actually start here, and the version of Weka we're running is 4.1. So keep that there, 4.1. And what it allows me to do is, if I actually scroll down the left-hand side, there's a lot of quick start guides. It talks about deployments in the cloud. It talks about how you can test Weka's performance. So you could even run it ahead of the game, how to test that with FIO. It talks about additional protocols that we're not going to be doing on the test. We're just going to be using the Weka client only as part of this. And it talks about things like upgrading and licensing. And we'll talk about how we're going to give you license keys to run that. One of the most important links, I believe, to talk about is prerequisites and compatibility. What do I really need to run and have for a Weka cluster. So this link here talks about the minimum CPUs that we support, and obviously AMD 2nd and 3rd, 4th Gen EPYC, Sandy Bridge or above, quite old. And then what we do is we have a list of different OSs for backends and clients that we have. So a lot of obviously people run Red Hat in a commercial sense, CentOS or Rocky. Good old Rocky Linux is now coming to fruition. We have a lot of customers also running Ubuntu 22.04. And then obviously this is out of scope for everybody on the call, but we also have people running in Amazon Linux and obviously GCP and AWS and stroke Azure as well, Microsoft Azure as well. And then literally, if you scroll down here, there's some notes around the kernels versions that we support. And I mentioned earlier on as part of the installation, we do expect to see a opt/Weka directory on the local Linux machine. And this is used for collecting logs. This is used for taking data from what the cluster is doing, things like performance metrics. So we expect to see some space available for that. And then literally, it's a real shame that we're not running multiple clusters, but if we were, we would obviously expect to see things like the network adapters that are joining the cluster together. I mentioned before the CX5, the CX6 cards, the Mellanox cards. And I think looking at the spreadsheet that was sent over, there is a few servers that we could look to use with these cards. Coming back and recapping, the reason we use these listed cards here is historically we want to use the system not in UDP mode, not in kernel mode. We want to use it in a DPDK mode, and these are the network cards that we've certified with Weka. So, and then the NIC drivers, you can see this as well. I'm not going to go through everything here. So this is certainly the place that I would go and have a read. As you can see here, the network speeds that we support, 200 gigabit, 100 gigabit, 25 and 40 plus, obviously InfiniBand. Totally irrelevant for you. We're not doing VLANs because we're obviously one-to-one. But we also have here, you can see here, some IP addresses. We're talking about how we address and drive that. So definitely worth a read, definitely have a look through. Please try and read through, understand, have questions for the next session. It's so important to get a grip of those as well. The other thing is getting support for Weka, obviously reach out to Dave and myself, and we can certainly help you there. The next thing we will also look at doing is where I log in and get the Weka software. So there's a tag get.weka.io. What we would normally do is get you to register, and you can still register here if you want to. And what we will also do is supply you with Weka keys for the license key for the Weka cluster. The cluster will actually start without them, but you do need to have some sort of formal key, and we will generate those for you for your single Weka cluster. Dave, is there anything you want to add here at this stage?
No, I think you've covered it all. I think so we can go into on the next session. We can go into it, and we'll actually can walk you through a deployment and see how it goes.
Fantastic. Yeah. So the whole idea of this session was just to give you a bit of a background. What I wanted to do also with this session is actually get on. I was chatting with David earlier on the other day, and I said, look, let's actually get on a session and actually show you where this is and how it's deployed, and think about the model that we could possibly use in the labs at ISC and how it would actually look. So I'm not a GUI fan. I don't think a lot of people that run AI jobs are GUI fans, but we do have a Weka GUI. So let's start off at the Weka GUI, and you can get to this. So what you would typically do is build your cluster, like I showed you back in the PowerPoint presentation earlier on. So if I go back to that, and let's just quickly start that back up. So what I'm doing here, I'm using quite an old slide for this. We have newer slides, but I still quite like this one, is I've got a host out here, and I'm going to connect to my Weka cluster externally on one of these ports, and this would be a single port in this case, at port 14000. So I'm going to log on and see the GUI of the cluster at that port. So if I go back to my graphical user interface, discard that, you can see here, there I am, port 14,000, and this is one of the IP addresses. And we have a default login admin, and then basically there is a default password. When you first create the cluster, it's admin, Again, we will document this for you, and then you normally, at the first time you log into the cluster, you change the password. So we've changed this one here. And this is the old graphical user interface. I'm actually going to show you the new one that you get today. Let me just quickly show you that one. This is one I was doing. So this is what you would get when you first log into a Weka GUI. So I'm just going to make it a little bit smaller. You can see that. So what is showing? So it's showing performance. The most important thing when people buy Weka is how fast am I really going? And we look at, with AI jobs, latency. We look at read and write throughput, and of course, total operations per second. And we're talking in bytes. On here, we're talking in microsecond latency. Here, not millisecond like old school storage. And then also we're looking at things like the active clients. Now, because in the lab, you will only have a single client and a single server, some of this is actually quite irrelevant, but I wanted to give you a bit of background around this as well. On the left-hand side, normally on our cluster, we talk about the data protection, and this is really important for large enterprise customers. Again, we will be running a data protection inside this single server. It's really just showing you what it would look like on a multiple cluster. And then what we're showing here is, if you actually have a look here, we have a thing called top consumers, and we talk about backends, and they are those physical servers that I was showing you that are glued together to produce that Weka POSIX file system. And then normally what we would have is top consumers, the AI servers that are attaching to the Weka cluster. The other one that Dave did today, Dave built this server, actually, this is running inside of Microsoft, Dave, or is this AWS? I can't remember.
This one's in Azure.
In Azure. Sorry, it's in Azure. Okay. So this one's in Azure. And then basically what we've got here is we've got 6 backend servers. And again, we can see this if you go to here, and if you actually have a look at cluster settings, there's the license key that I was talking about, and we're talking, this is unlicensed. But if I actually go to cluster servers, we have 6 backend servers. What you will actually see on your version, and we'll cover this at the next session, is how we install this type of environment onto a single server using multi-container backend. The other thing it's showing is CPU cores. It's showing the version of the software. It's showing the drives. So there's only one drive on each of these. And you can get a detailed view here of what each of these servers is doing. So it's a single server. It has 3 nominated cores, really small amount of RAM, single drive, all of the other services, NFS, S3 and SMB. Enterprise type features are disabled, more on-ramps. We're using the Weka cluster. And then what it shows here is the drive, compute and front end. These are the processes and the amount of memory and what's active on here as well. And you can actually see, if you could do edit container, you could actually see a breakdown and change those. And then looking down here inside those containers, you can see the processes, the drives, compute and front end against each of those processes, and the drives here that's been mentioned. So you can actually have a look here. There is a quirky 3D view if you like that as well. So there's our 6 servers running. And what we're going to do is glue together all of those drives to produce a POSIX file system that we can present to the GPU cluster. Everything that you can see on the GUI here, I can see on the command line interface. So this is the command line interface. What I've done is I've SSH'd into this server here, IPA. So here I am running 10.0.10.7. That's one of these. Where is it there? That one there. I've joined that one. I've SSH'd onto that server, one of the backend servers. And then basically what I'm going to do is, if I just type Weka, and again, we'll show you this depart there. There is around about 29, 30 commands that you can use on the command line for Weka. It's all got autocomplete, so you can do that if you're not sure of the command. So starting with the basics, rather if you didn't want to look at a GUI, we will show you how to deploy a Weka cluster on a single server. The next step is typing Weka status, and it's telling me that the cluster has got 3+2 protection. If you actually have a look down here, it's showing me probably the most useful thing in terms of how long it's been up and the usable storage and what is unprovisioned. So the next thing we got to do is we want to create a file system across those 6 servers. So if I just type Weka FS, it's showing me I have 2 file systems on those 6 servers. And what we can do is we can create a brand new one, a brand new file system. So I can type Weka FS create. I can give it a name, test FS. I can give I'm going to give this one default. This is to do with the tiering piece. I'll cover off this there, and then I can give this a usable size. I don't know, 1 terabyte, really small, 1 TIB. That is it. That is simple Weka FS. Type correctly. I've now created a 1 terabyte file system that is distributed using erasure coding across all of those nodes. And then what I can do is present that test file system to a GPU box. I can mount it very much like I mount an NFS share. So I don't know if people are familiar with mounting NFS, but what I can do is make a directory. And this would be on your GPU box, make a directory MK, let's call this MNT test. Oh, I've got to do this with sudo. It's a good start. And then basically what I can do is I can actually mount that file system. Now I'm going to mount this locally. It's actually, we're mounting an internal mount. So it's the backend service, a bit like hyper-converged. We're mounting to the cluster from one of the nodes inside of here, but this would be done on an external client. So what I can do is type mount -t Weka FS. Again, we can show you this. I can give it the name of the file system, test FS, and then I can give it the directory test FS. Now I'll have to do this as a sudo, obviously. And then if I type df -h, you can now see that test FS has been created. I could then go into test FS. Actually, I'll tell you what, I'll sudo to root, say, because I'm lazy typing. So it's -i bash. I can then go into mount test FS. MNT test, apologies. And now I can start to create files. I can touch a file, ml.txt, ls, and I can actually now, I'm actually writing data to that file system. If I type a df, you can see there, test FS, that's where I'm mounted. And I can actually see mount -t Weka FS. There's the default mount options that we've given for that mount. So Weka is really easy to deploy. We're going to help you with scripts. We're going to show you how you can connect to this backend server. We're going to explain about how we can set this up. The idea is Dave and myself will give you some bash scripts to set this up so you can use it as part of the labs that you'll be working on. We can also answer questions. You can change things around Weka, the workloads that you're doing with your AI jobs. But we want to keep this really simple, really efficient. We want to see the back-end performance of that grow. If we can show you some benefits of using Weka as part of that lab or your lab tests. And the idea really is to show you the flexibility of this. So what you can do, as you can imagine, is we can, at the moment, we've created a file system here. And if I go back to the GUI and I look under manage file systems, there's my test FS. What I can do is by detaching that local storage and putting it onto a Weka cluster, I can do some very clever things. I can create separate file systems for separate workloads. I can grow and shrink up and down that file system live. So I could make this 2 terabytes. There we go, it's 2 terabytes. I can go back if I type df, du. Let's have a look at this. Let's do a du, df, sorry. You can see now I've got, as a human. You can see we've got 2 terabytes, so we can grow and shrink file systems. And this might help you in some of the labs by creating areas to stick data onto using a Weka backend. Dave, is there anything you want to cover off at this stage?
No, I think you've covered all of it. It's very similar to use, easy to deploy. We can give you systems for all the scripts.
Has anybody got any questions on this? Ofer, is there something you'd like to ask us at this stage?
I would say to the teams that this is optional. I mean, they can decide if they want to use it or not in our benchmarks. We can supply all the help, and I'll upload this video also to the website. And you mentioned earlier the Slack channel. We have a Slack channel for the teams, and I'll add you there just in case anyone has any questions. We can review them if anyone wants to use it. I think that's it on my side.
Super. Yeah. So this is optional, right? You don't have to use Weka. It's there as a tool to help you with your tests.
Yeah.
There are benefits. It might be worth trying some things out, but yeah, it's an optional thing. It's a tool in the toolbox to hopefully get you to win this. Again, the Slack channel that we're joined, Dave and myself can answer questions. If you want to have access to another system to play around on, we can certainly help you with that. But the most important thing is we want you to win, right? So if you can leverage Weka and win with it, and it does give you a competitive advantage in the teams, please reach out and use it. So we've got coming up to the hour now. I think there's no questions. There's quite a lot that we've covered off here. As I said, all the commands here are listed out here. I can type Weka cluster. And again, I can break down, and again, we can go through this with people at any time that they want to break down the commands. We can go through this with people and show people how this is listed. We can talk about the resources. Again, that's a part of the second thing about how you consume resources for Weka and how you could actually mount the file system as well. What we're not going to do is, on this particular experiment and labs, is use other protocols. Weka does support NFS, it does support SMB or SIFT sharing. These are more on-ramp protocols. NFS is too slow, it's not for speed. Weka is a POSIX client, it is significantly faster than an NFS mount, and it should be at scale, depending on the number of servers you have, significantly quicker than local NVMe storage. So lots of questions around that. The last thing is probably I was going to cover off now is around performance monitoring. So if you choose to deploy Weka, and again, you don't have to, but if you choose to deploy Weka, we have the ability to look at the events of what the cluster's doing, but probably the most important one is looking at statistics. So if you're running a job, an AI job, and you point it to Weka as a back end, and you want to understand the operations per second that your AI job is working on, you want to look at the throughput in bytes per second, really important, and you want to look at the read latency, is it read intensive or write intensive? All of this can be reported inside the GUI. If you really have a lot of time, we also have a REST API that you can literally call REST API on a Weka cluster, and it will give you updates around what the file systems are doing, the containers, the backends, the drives you're doing, so you can leverage this. A lot of customers use this as well as part of their scripting. We also have the ability to give you reporting on the system usage through the REST API as well. So there's a lot of information here. The key place to start, I would certainly come to, is the Weka docs page. If anyone's got any questions, mark@weka.io, david.ranson@weka.io, please reach out to us on email, and we'll obviously be on the Slack channel. We've got a second session coming up. David, 2 days time? I'm not too sure actually what date we put that second session.
On 2 weeks.
2 weeks time, apologies,
Yeah.
after Easter.
You can bring it forward if you think it would be beneficial. So
Okay, let's discuss offline. See?
Yeah, we'll discuss offline.
I see Panos want to ask something. Panos, go ahead.
Yes. My question is this Weka system installed in the competition clusters, or should the teams install the software?
So it's optional for them to use it. We are trying to give another option if they want to use. If they want to use it, we just bring it as an optional. It's not mandatory. It just came out late, so if Teams wants to experience and to learn about that and to see other options, they can try it. So that's the focusing more on the online teams.
Yes.
Sorry, on the on-site teams. On the on-site teams, the online teams, we have 2 clusters, and we don't have Weka over there, so we cannot practice with that.
Okay, thanks.
Any other questions?
Yeah, thanks so much for the presentation. Could we maybe just get access to the licenses so Teams can prep deploying and installing now, just on our virtual machines for the time being, just that we're not rushing come competition time? Thanks.
Yeah, absolutely. So we will give you access to the software. I'm a big fan of, go ahead, play with it, break it, come back to Dave and me with questions. It's your time, right? We will invest as much time as you need us to help you leverage this technology, measure this technology, and get to learn this technology. But it is optional, right? We're very late to the game. It's there. It's a tool in the tool bag. It should make, for certain workloads, a difference.
Yes. Some things also, sometimes whatever you take from the competition eventually to your life, it might help you later on whenever, all the teams, whenever they're going to work, they would know about this option, and they can, take it to their future, to their life with that. So take the, this is an advantage if you want to, drill in, try it. We'll send you the emails of Mark and David, and they can help you with the licenses, and we'll add them to the Slack channel for any questions. And we can continue from there.
Yeah. The other area I did want to send you, last thing, I apologize, I missed it, was we also have a Git page. Git. Actually, I'll just quickly show you, actually. Let me just get back onto my Git page. So we have a Weka tools page. I mentioned it earlier on. Again, I'll put this in the presentation. GitHub weka.tools. Please go there. You can actually just Git pull this down. You can clone it straight away. There's all the tools that we're talking about, post-sales, pre-sales. All of these tools are available for you as well. So you can have a look at this. It talks about how you deploy it. Again, we're going to cover off a deployment in 2 weeks' time, or whatever it's going to be. We can bring that forward, so we will discuss that if people are really keen to get on there and have a play and learn about this. Dave and me will give you the software link, so you can download the software and use it, and obviously we can generate the license keys as you require that as well. We also have things like scripts, as I mentioned before, and again, we will cover this off later on around, see if I've got one script here now that I can show you. No, I haven't got one, actually, it's a shame. But we have some scripts that we can show you creating a single, it's a bit like a virtual Weka cluster on a single host. It's a real shame we haven't got lots of nodes because we really want to drive performance. But in the real world, the bigger world where people are running this in production, they obviously do deploy Weka on multiple nodes to drive that GPU workloads. Okay, I've got 8 minutes left. If there's no other questions, I'm going to wrap up.
I just wanted to ask quickly, sorry to interrupt you, just for the teams though, because obviously things like these and other parallel file systems, they scale really well with the number of nodes, right? It's for our students, is the squeeze worth the juice at the end of the day? That's what I want to ask, because it's not a trivial amount of work, right?
Yeah, exactly. It's one of those questions I don't know, right? Are you going to get a benefit of running Weka on a single node at the back end? We will also investigate trying to look at extra nodes for you, things like that. But it's not, I mean, it's worth having a look at. There should be some advantages, but it depends on what you're doing. Yeah, as I said, this is just an introduction. It's a way to learn it. If it's used, great. It is purely optional. Maybe in the future, if we do more labs around this, we will look to deploy Weka on multiple nodes, and then you can really measure the performance benefit that you get from a truly parallel scalable POSIX file system. Good. Well, it's been a pleasure chatting to you. Thank you so much for your time today. We're top of the hour. Again, please go to docs.weka.io. Please go to GitHub. Reach out to Dave and myself. We're here to help you as you go. And I look forward to being on the next session where we will go through an installation with you and how you actually deploy Weka. So thank you very, very much.
Yeah, thank you all.
Thank you.
Bye-bye.
Thanks.
Bye-bye.
Thank you.